Okay, so today we are talking about applications of logarithms. So basically your problems are going to be both really difficult math, like problems involving log. They look really scary, but since you have a calculator, they're pretty easy. And then there's application problems. And one of the application problems is about a steep beach, like how steep a beach is. So here's a picture. I had you guys Google it on your iPads. And this is the picture I'm looking for. That is a really steep beach. And just look at it. If you were walking on that beach, you can see how you'd have to, like, your right leg would have to be like, 8 inches higher than your left leg as you're going down the beach. And when you have a really steep beach like that, it's based on something. It's not based on how windy it is. It's not based on the mountains in the background. Does anybody want to take a guess? What do you think makes a beach steeper than another? What do you think? I'd guess. What do you think? Guess was a yes. Yeah, there is such a thing as a riptide, and the that can kind of change. Cause like beach to be. Riptides would only be like a little small area, like let's say it could be a riptide going out like right here, and that could cause a little bit of an indentation in the sand, but not the beach. But I like that you come with a very creative idea. Is it the kind of sand? Yeah, it is. Know that. Kind of the beach steep or not? Well, what kinds of sand are there? Fine versus. Take a look at this beach. Can you tell by looking at it whether it's fine or coarse sand? It is not. It means that it's really. Have you ever noticed that on those kind of beaches your feet much? I mean, super. If you're walking along. And I know that's kind of counterintuitive. You'd think it's really small particles, but when they're really small particles, aren't down more? Get what I mean? All right, so I'll show you the difference between this, and it's not just my theory. I have an actual math equation to prove that it's like how big the particles are. But let's do another search, except if you search for a flat beach, it really doesn't give you many good pictures. I want you to go to Fort Myers Beach. Do a search under Fort Myers Beach, and this picture, the second picture that comes up as a good one. But this, if you want to get a perspective, a lot of people go here from Minnesota to Fort Myers Beach. It is a beautiful beach. Let's pick this one. And do you notice how flat that is compared to the other one? It's almost like a street. And if you've ever been on, how many of you have been on Fort Myers Beach? Raise your hand. That's like 3 or 4 of you. All right. That beach has super fine, like sugar sand. So particles, the flatter. I started to notice this when my brother said he would only go to Fort Myers Beach, not this other beach that I liked, because his wife had her hip replaced. And when you've had a hip replaced, apparently you can't walk on uneven surfaces well. It's really hard for the replacement hip, not mechanical, but whatever, hip can't really handle flat, so you walk on flat things, you're fine. So he likes this beach a lot because it's flat. All right, so anyway, here's a math equation. It happens to have a log in it, real world, and it helps you figure out either A, how steep the beach would be if you had particles that were this big, or B, if you want the beach to be a certain steepness, then therefore, how big should the particles be? D is the diameter of the sand particles, and S is the steepness of the beach, or the slope of the beach. All right, so if you were going to do this one, you just need a calculator, and you're going to take this diameter of the sand is 0.25. It's so easy. There's only 2 places you could put it, and D for diameter seems pretty logical, and so you pop it in there. And then log base 10 of whatever. In this case, it's log base 10 of 0.25. Don't do it the slow way. It would be to take log 25 over log 10. But you really know what you're doing. When you type it in the calculator, log base 10 is what you're doing in the first one. Yes, so you don't need to divide by log base 10. Because in this case, since you're doing a log 10, the one your calculator does is base 10 automatically. So you just have to type in log 0.5, and it will assume that you're talking about base 10. So go ahead and type in log 0.25. What do you get? Negative. Yes, that's okay. Negative what? 0.6. Okay. So I'm going to take that, and now this whole thing right here gets replaced with negative 0.602. Then take that and times by 0.118. That's this part. Times by 0.118. Now, negative 0.071. Then add that to 0.159. What's the final answer? S came out to what? 0.088. That means the slope of that beach should be 0.088. You're not used to slopes so small, but think about it. Beaches that are pretty flat are going to have a slope close to 0, right? And that's pretty close to 0. So that's a pretty small sand particles. If there is a quarter of a millimeter, holy cow, just think about it. 0.25 of a millimeter, how small is that? Well, a millimeter is like the width of a pencil lead, and then you go a quarter of that. Those are pretty small, and that's the diameter, not the radius. It's the diameter of the pieces of sand. So if your diameter was 4 times bigger than that, of course, anyway, you could do the math on it. All right, determine the average diameter of the sand particles if the beach has a slope of 0.5. That's the bottom problem there. Well, then you've got to put that in for F. So how are you going to solve that one? That's a little harder. If they give you the number on the other side of the equals, this is 0.5. Slope has to be 0.5. Then I have to solve this. First thing I do is get rid of this, subtract 0.159 from both sides. Then I would divide by 0.118, gets rid of that. And then I'd be down to log base of D is equal to whatever number I came up after I subtracted it, divided by that. So I have some number. And then I have to do a rewrite and say 10 to the small number that you have is D. All right, so I'm kind of crippled by the fact that I don't have the decimal there, but it really isn't too bad. All you have to do is end up taking 10 to that power. All right, so I guess the next part is some really, really hard, scary-looking math problems. Everybody, please get to a blank page. And this one, even though it seems super scary, is doable in your head. I'll get on it. You don't have to write the problem down, but you do need to write, after we do the first step, you'll have to write it down. Do you get that this right here needs to get done because it has numbers in it? We can do that. Now, if you had a calculator, don't use the calculator, though. Don't use the calculator, because this can be done in your head. Somebody knows the answer already. It's not 2. 3. Good. Because 125 could be written as what to the what? 5 to the third. And you remember that deal where if this number and this number are the same, then the answer is that number? Remember that? All right. So final answer to what's in the box there, this whole thing, is 3. So now it's 6 times the 3. What's that make? So everybody, from there on, you solve that on your paper. You may not need much more than one more step. Much easier. Once you've got the log out of there, it's like a piece of cake. Yeah, it's just a simple algebra. I want to pause for a second and orient the board. All right, so I hope you put the 18 and the 5 together, made 23 equals 5x minus 7. Then you should have added 7 to both sides, makes 30 equals 5x. And then you should divide by 5, and you get x equals what? Yes, raise your hand if you had 6. Okay, good. Now, here's a hard, but really not that bad if you know how to do. See if you can handle it by yourself. Start by getting rid of the 2. I'll pause for a second while you're working on it. Okay, so you should have started by dividing by 2. And then you get this to disappear. Log base 6x of 16 equals negative 4. And then I'm going to put 6x to the negative 4th is equal to what? 16. So I want this to the this equals that. Raise your hand if you were right so far. Okay, good. Now what am I missing? Do you know? And there's something wrong with what I wrote. Something slightly wrong. Yes? Parentheses, yes. Why? Because this whole thing is being put to the negative 4th, not just the x. Does that make sense to you? The whole thing needs to get put to the negative 4th. And if I write it without the parentheses, only the x is going to get put to the negative 4th. All right, so next part. How do I get rid of a negative 4th power? I put it to the 1/4 power, but that wouldn't take care of the negative. So if I put it to the negative 1/4 power, that would fix the negative. And a lot of people think they need the calculator right here, but they don't. Because really, 16 to the 1/4 power is the 4th root of 16, and then flip it. That's what. So what the 4th root of 16 is 2, and then you flip it, and that makes a half. See what I just did here? I took the 4th root of 16, that's the 1/4 part, and then the negative part tells me to flip it. All right, so I'm almost done. And instead of dividing by 6, because this would be ugly, I'm going to multiply by what? 1/6. Good. 1/6 here and 1/6 there. And this part will cancel, and I get x equals 1/2 times 1/6 is 1/12. Raise your hand if you had 1/12. All right, that's 3/4 of you. But if you did make a mistake, I'm guessing it's because you got stuck in here and you didn't know to get that to be a half. Give you that was the sticking point. There's a few of you. All right, thanks for being honest. All right, let's go on to another one, and this one looks particularly scary. As soon as you realize that if you rewrite it and do a change of base, you can do it without a calculator. If you had a calculator, you just type exactly what you have here. But calcs won't be allowed in this kind of question. Otherwise, you can just type it in. I can get like a 3rd grader to type that in. But you have to be able to solve it with changes of base. Okay. All right, so there's 2 different ways you could do this. One of the students suggested I take the 9/4 and rewrite it as a 16/81. So that'll mean I have the 16/81 here. I'll leave that alone. And I'll take this next part right here. That's where all the hard work's going to happen. And take this and write it as a 16/81 to a power. And what would the power be? To the negative, I'm not sure. I think it's just 2, isn't it? All right. Now, how do I know that? Because if I take what you just said, though, something that's not going to quite right still yet. Do you get how if I go 16 to the 2nd power, that's going to be a huge number? It's not going to be 9. You're close. You're doing it a hard way, but it's going to work if you do it right. What do you think? Yes. The negative 1/2 power. Here's the thing that's hard to see here. This right here is actually exactly equal to 9/4. Now, why did we go to the work to rewrite that? Because if this and this are the same, then that's the answer, and the answer is negative. There is another way you could have done this with a rewrite, and I think it might have been slightly easier, but it's going to come out to negative 1/2. Oh, sorry, 1/2, not a negative 1/2. I screwed up. I'll show you where. All right, right here. when I said that this was a half, I was right about the half part, because we need to take the square root of 16, and then they have to get the 81 to be the square roots of them, and that would be 4 and 9. Wait a minute. Maybe it is a negative. It's 4/9. I have to have the negative to make it flip. So it's 9/4. Oh, I get what you're saying. Okay. If this whole thing over here is negative a half, then I have a negative x left over. So I have negative a half is equal to negative x, and I just haven't finished. That's all. How do I finish? Divide by -1 is a good way to say it. Divide by a negative, it just changes the sign, and you end up with 1/2 equals x. Sorry about that. Okay. So the I was going to show you that I think is, for me, it feels easier, and everybody has to be their own judge of what they feel is easier, is to rewrite this puppy. I would go this to the this equals that. I would say 16 to the 80, or 81 to the negative x is equal to 9/4. And then I see that this and this could have the same base. They could have a base of 9/4. So I leave the 9/4 alone. I take this one. I still have to do that process of figuring out what to do. But if I know that I want the answer to come out to be 9/4, I can just say 9/4. And then I got to figure out what power do I put here. And the power I need to do is same deal. I have to have it flip and get bigger. So I need the flip part here. And I need it to be a 2 in this case, right? Okay. Now, here's the part that to me, this feels easier because I didn't have to do the square root. I just had to do it to the power of 2. Now, you might think, well, there was a half. Now you're coming up with this, that -2 times negative x to the exponent over here, which is a 1. I go -2 times negative x has to equal 1, because this has to equal that. And that means 2x has to equal 1, so x has to equal 1/2. Now, I don't know. That felt easier to me, but then that's an opinion. So, either way, answer's a half. All right. Let's do one more of those, one more of those application questions. And the way we do applications with logs is mostly we're going to give you a formula that has a log in it. And all you got to do is figure out where to stick the number they give you. These are pretty easy. We call them plug and chug kind of problems. And they exist a lot in the real world. A lot of times your boss will know what the formula is for the amount of oil in the pipeline or whatever. You just have a formula they give you. And then you stick the number in the right spot. So where does a 60-inch antler spread go? Probably the A. Feels like it'd be the A, but I can check up here. Antler spread A in inches. Okay, so then I just have to stick it right there. And then the other thing I'm going to figure out is H. So once I stick in the 60, I have 60 plus 40 is 100. And then I have a little log problem, log base 10 of 100. All right, and that should be an easy one for you. It comes out to 2. Then once you could probably even do this one in your have a calculator. All right, so your assignment is a bunch of questions just like that. You can find that I did several of the homework questions for you. All right, so relatively simple day from that perspective. So pull up your Schoology account, find the one assigned for today, which is 4-18. I think it's called Logs Day 7, and in case you're paying attention, Logs Day 6 doesn't exist. Yeah, it's one of those secrets of mankind. There is no Logs Day 6. So you just went from Logs Day 5 to Logs Day 7. I just heard somebody's mind explode. All right. Okay, I did realize there's one more thing I need to teach you before tomorrow, because tomorrow some of my classes will be shortened. It's just about graph logs. If you're going to graph a log, you got to remember what exponential is. That's an exponential. It's y equals, let's say, 2 to the x, or 3 to the x, or a new one that you've never heard of, e to the x. E is a number. Just like pi is 3.14. E is a number. It has a 7 in it. 2.18. E is 2.718. And if you put e to the x, then you're really putting 2.718 to the x, which is pretty much like y equals 3 to the x. It's pretty close. It's it's fairly close to the right answer to just say 3 to the x. But technically, this graph right there, and it's a little too steep. I should make it not quite so steep. That's y equals e to the x, or just kind of like 3 to the x. Then the line y equals x goes like this. That's just equals x is called the identity function. And then if you flip this over that line, you get this. And that is the graph of log. These three go together, and this is a big deal in calc. And it's specifically, this is the natural log of x, as in ln of x. And that probably went way over your head. But that blue one, that's a new parent function that you haven't seen before. Okay? And there's two kinds of logs you have to know. The kind of log goes like this, and then there's another one that's just a little more, a little less steep. And it basically goes like that. And the log graphs, those parent graphs, there's two of them. There's y equals ln of x. That means log base e, that new one I was telling you about. And this one is y equals log x, which means base 10. If I don't say what base is, base 10. All right, now which one? Which? The bigger the base, the closer it gets to the axis. So this green one is like this one. And ln log base e, it's like log base e. That means log base 2.718. So that's not as steep. So the black one is the black. Right, so basically you've got a couple more parent functions, so big surprise, we're going to, just like we did before when we did this, we go like, oh, -1 means move it to the right 1, +3 means move it up 3. You're going to be stretching and stuff with the logs. If you have log x, and then I go like this, you'll take the log graph and take a wild guess. Where are you going to move it? Left 3, yep. And then what if I want to put a 3 out in front? It's going to make it times as tall, same kind of thing. All right, so that's the basics of the graphing that we'll start tomorrow. All right, we'll talk more about that tomorrow, but at least we won't.